Hello students, welcome to the subject design pattern, course code SAT 304. Today we will study iterator design pattern. In today's session we will start with the introduction of iterator pattern, then we will see some motivations behind of using iterator in code, and then intent and examples from real world as well as application level. Then we will see the UML representation, code implementation, and then conclusion. After learning iterator design pattern, you will be able to traverse different kind of data structures in uniform way because it provides a uniform interface for traversing multiple aggregate structures, that is to support the polymorphic behavior in iteration. It will help you to access and aggregate objects contents without even exposing its underlying or internal representation. Iterative design pattern is very commonly used in different languages such as Java, .NET, C++. Almost all high-level APIs facilitate you to use iterator for traversing of different data structures. This pattern is used to get a way to access the elements of collection, different aggregates objects in sequential manner such as tree, list, array, queue, stack. You don't need to know the underlying representation of data structure. You have to simply use the uniform iterator to traverse all different kind of data structures in uniform way. So this pattern falls under the behavioral category because it helps you to change the behavior of using different data structures. An aggregate object such as list, graph, tree, arrays should give you a way to access its elements without exposing its internal structure. As you know, that all data structure have different internal structure. For example, array works based on some index-based system, whereas the queue has different mechanism. Similarly, when you want to traverse the stack, it has different access system, and trees and graphs are basically non-linear data structures, but to traverse and to run the operations, you have to design a generic iterator which will help you to iterate them in a uniform way. Iterator provides a uniform traversal interface for different data structures. For example, as I have told you earlier that in start you have learned many data structures which can be linear or non-linear data structure. For example, array, list, queue, stack, uh, graph, tree, and so on. The key idea of this pattern is to take the responsibility for access and traversal out of aggregate object and put it into the iterator object. What does mean by the aggregate object? You know that you have two different kind of data types, primitive data types and non-primitive. The primitive is a basic data type which store only one type of information, and it's not a single in number. For example, when you want to store a number, then you might take integer data type, and if you want to store a character, you can take the character type data type. But what if you want to store a large number of information? For example, you want to store the numeric data with the length of 100 or 1000, then you need to use the aggregate objects or aggregate data structures, as you might use array or list. So the common data structures in software development also use the generic or the collection based methods. A collection is just a grouping of some objects. A collection can be list, it can be tree, it can be hash map, and the examples can continue. So you might be have been using different collection of items, storage in different data structure. But the important thing is that instead of creating the different mechanism, different operations, and different accessing and traversing method for different collection, it's good if you design a uniform way to access the elements without even exposing their internal structure. So by using the iterative design pattern, we have a mechanism to traverse the all data structure in the same way, regardless they are array, binary tree, hash map, or queue or stack. It doesn't matter how they are internally represented. The iterator will be the same. It will provide a generic, a uniform interface to all clients. If they want to access or traverse using list or array, they don't need to know the underlying representation, the complex structure, or they don't even need to understand the complex structure of each and every data structure individually, because the iterator will provide the same operations to access and to use and to manage any data structure. The common operations will be adding elements, it will be deleting elements, getting element from the current index, and similarly it should have some generic methods, such as if you want to move to the next index, the next operation, and the back traversing methods. So the most high level languages are already providing you such iterations. You might be using in Java or in .NET. They are providing the iterators for traversing the list, the queue, and the stack. And the iterator provides very generic and uniform methods to access them and to use them and to traverse them. So the idea of the iterator pattern is to take the responsibility of accessing and passing through the objects of collection and put it in the iterator object. The iterator object will maintain the state of iteration. It will keep the track of the length of any data structure, the current index of the data structure, and it will check then if the next element is found or not. So it will keep track of the current item and having a way of identifying what elements are next, and when to end the traversing of data structure based on the length of data. So after getting the background understanding of iterative design pattern, let's come to the intent. It provides a way to access the elements of an aggregate object sequentially without exposing its underlying representation. It means that if the data structure is linear or it's non-linear, such as we know that the arrays, the list, they are linear in their representation, whereas tree and the graphs are non-linear data structure, but they all are aggregate. Why they are aggregate? Because they contain the collection of items inside them. So instead of knowing the underlying representation and their complex architecture, the user will simply use the iterator to access them and to traverse them. So it will enable you to create a general purpose GUI component that will be able to iterate through any collection of the application. It doesn't matter that which data structure you are using, you have the same the basic operations and their same representation for accessing the data and traversing the data. Iterator design pattern can be applicable in any kind of data structure which store data in aggregate form. It means which store data in collection. When you have multiple information, you have a large number of data. So the collection can be a list, it can be a set, it can be array, it can be stack, it can be queue, or it can be non-linear, such as graph or tree. You can implement the iterator design pattern for every kind of data structure. To understand the working of iterator pattern, let's take the example from real world. You know that on early television sets, there was not such a kind of remote with the digits and anything where a dial was simply used to change the channel. When channel surfing, the viewer was required to move the dial to the each channel position, regardless of whether or not the channel had reception. Whereas in modern television set, you have a remote which gives you a next and previous buttons. You don't even know the frequency of the channel or the number of the channel. You can simply iterate through all the channels using the next and previous button. So the viewer select the next button, the next tune channel will be displayed. So this is a basic example of iteration that you don't understand. You don't need to even memorize the numbers of channels, the frequency behind of the channels. You simply use the iteration of the channel using the next and previous button. By clicking the next button, the iterator will simply move and jump to the next channel, the very tuned channel, and the back button will help you to iterate to the very back tune channel. Similarly, using the iterator design pattern, we will be traversing different kind of data structures in a very linear way, regardless they are of any type, um, tree, they can be stack or queue. This is the general UML representation of iterator design pattern. You can see these are the main participant classes. The firstly we have the iterator class. Inside the iterator class, there will be all methods and operations that you want to provide for accessing, deleting or deletion or the management of information. The iterator basically defines a generic interface for accessing and traversing the elements of any kind of data structure. The concrete iterator will be implementing the iterator interface. It will keep track of current position in the traverse of aggregate. It will contain the definition and actual implementation of iterator. The second is the aggregate interface. It defines an interface for creating an iterator object. For every aggregate, there will be a separate iterator. Means that it depends on how many repositories and how many different kind of data you have. If you have list, if you have array, or if you have information in numeric or character, to traverse that type of data structure, the separate iterator will be implemented using the concrete iterator class. The second is the concrete aggregate class. It implements the iterator creation interface to return an instance of its concrete iterator. To understand the working example of iterator design pattern and to convert into the code, let's take the simple example from a very simple scenario. Let's say we have a list or we have a string or array of characters, and we want to write a generic iterator to traverse and to access the elements of this list. So firstly we have the container interface. The container interface will provide the reference of its iterator. The iterator will be used to iterate the data inside that container. And there is a second concrete class of container which is named repository. It will contain the data. As you can see, there is the data structure of string, or you can take the array of string, and it is implementing the get iterator method. And similarly we have an iterator interface. The iterator interface will provide the signature of all the methods that we want to use for accessing the elements of string. And the concrete iterator is name iterator because we want to iterate the list of names. So in this scenario we are writing an iterator for traversing and accessing the elements of name list, and it will implement all the procedures which are declared inside the iterator interface. This is the first interface of iterator class. It has the signature of all methods. Simply here there are only two methods, has next and next. You can write as many much as methods that you want to provide for accessing and traversing the elements. You can write here get previous. You can write here check length, and all the methods that you want to write for operating any data structure. This is the interface of your repository class, which is container interface in this case. It will give you the reference of the iterator which will be using to iterate that container repository. So here we have signature of iterator. The next class is the concrete implementation of repository or the container class. So the name repository is implementing the container. You can see that inside this repository or the container class, we are actually we are actually having a data structure, an aggregate object which is of names, and it contains a collection of different names, the items of collection. So this is an aggregate object, and we have to write the iterator for traversing the names. and you can see that the only data here is only three names or four names, but it can be large in number depend upon the requirement. The next is the definition of get iterator. It's returning the type of iterator, and inside this repository we will give the reference of concrete iterator which will be used to iterate this name repository. So to traverse the name data structure, we are writing the name iterator class in the next code. Here is the implementation of name iterator. So it's also implementing the generic iterator interface, and using its inheritance, it can override and provide the actual definition of all the operations. You can see that we have declared the integer index data type. This will be used to keep track of the state of index. The first method is has next. It's returning the boolean. It will check that if the name or the string has further item. It will return the true if the current index has not reached the limit of length, and otherwise it will return false if we have reached the length of name till the end of the list. Similarly, the next is the definition of next operation. It will check if the next element is existing, that it will simply adding into the current index and returning the data in the next index. And if the next is not found, then it will return simply null. So you can define and you can override all the methods which you have declared inside the iterator interface. This is our demo class. Inside this we have the main method. You can see that the first in the first line the name repository instance is being created, and to access the elements of name repository we are not manually accessing it, but we are using the iterator. And simply you will use the reference of the iterator inside your for loop. You can see that there is the starting and the terminating condition. The loop is being initialized with the start of the iterator. It is requesting the name repository to return the is iterator is required iterator, and the loop will be continued till we will iterate the end of the name list. So inside the loop method, the first index is returning its data, and it will be returning the names of all inside the name repository or the name container. So you can see that this iterator is simply keeping track of the limit of the data, and it will be ending based on the condition of has next method. This is the output of the program. You can see using the iterator class, we are able to traverse and access the elements of name repository, and it is printing one by one all names. So you can see that instead of the client is able to access the elements of name repository by using its iterator instead of manually accessing and manually using the initial and the terminating condition inside the for loop. It is he's using or able to use the iterator class and its method for traversing and accessing the aggregate data structure. So we have learned that the iterator design pattern supports the polymorphic iterations of aggregate data structures. It means that if you want to support different kind of data structures using the same way, using the uniform traversing mechanism, then you can write the iterators for each data structure. In this example, we have just written one iterator for one kind of data structure, which is name and the name iterator. But it depends that how many data structure you want to support. So you have to write the concrete iterators for each data structure. So using the iterator design pattern, client will be able to traverse the complex aggregations in a uniform manner.